Hey, algebra class. Okay, so as I said to you guys on Zoom, we're going to continue with parabolas today. We're going to go based on what you know to the best of your ability. So, parabolas, and I'm trying to make this thing work a little better, but it doesn't seem to work. So I'm going to have to go back to school and get my whiteboard. So, parabolas. We have the typical 4 graphs, and hopefully you remember that these were the U-shaped graphs. So we have 4 typical types of graphs where the graph looks like this, and we talked about this on our last day, I believe. So this would be like graph 1. Graph 2 would look something like this one, but upside down. 3 is where it comes down. It barely touches the line. Oh, I didn't get it to touch the line. Let's try that again. It goes down, it touches the line, and it comes right back up. Okay, so it only has one spot of contact. And then the 4th graph, okay, is, you might have guessed it, it doesn't touch anything at all. And that could be up there, or it could be down here. But the idea is that it's not touching the x-axis at all, right? So we're really focusing on the x-axis on this. So hopefully you guys remember that we are dealing with y equals ax squared plus bx plus c. And so what are these cases come from? Why do we have these things? So typically we have these things where we have 2 for both of these situations. We have, for number 1, we have 2 spots where it touches the x-axis, right here and right here, where this one also does, but obviously the graph looks a little different. This one only touches it in one spot, and this doesn't touch it in any spot. So why does this occur? So when you factor, we typically, if you can factor, then there's going to be some spots where we touch. So let's recap a little bit. So here's a little recap. We did, let's say A, we did something like x squared plus 5x, let's say plus 6. And we did another one where we had a was bigger than 1, so let's say 3x squared plus 6x plus 3. Okay? And since we can factor these both, we know that the graph will cross the x-axis at least one time, if not 2 times. And so A ends up turning into x plus 3 times x plus 2. And this one, after we do all of our work, we'd have to, move this on over and factor it, and then divide by the 3 again. You would get factors of 3x plus 1 and x plus 3. You can practice those if you would like to get your brain sharp. But what are we talking about here? So in the first situation, in A, because x plus 3 is one factor and x plus 2 is another, you might recall from the last day of class that means that if we are going to try to touch the x-axis somewhere on that line that we talked about up here, on this x-axis right here, okay, then that means that y has to be 0. And if y is 0, that means that y is equal to all of this. That means that one of these two have to be 0, or both of them. So x plus 3 could equal 0. I'll change back to that other color. X plus 3 could equal 0, and or x plus 2 could equal 0. And so that would mean we would have x is equal to -3 and x is equal to -2. So that would be our 2 spots in where we touch the x-axis. So if you could imagine over here, this graph would look something similar, but not exactly the same as, let's see, if we are at 6 and we'd somewhere touch at 6, we would go down, come right back up, and we'd touch somewhere around that area there. It would come down and come back this way, kind of sharp, and it would look something like that. Where B, would be a little bit different. Okay, so B, we'd have 3x, oops, wrong one, 3x plus 1 equals 0, and x plus 3 equals 0. And so we would get x equals negative 1/3, and x again equals negative 3. And so this would be very similar to this graph, but it would be at negative 1/3 and negative 3. So again, we have two factors, so we're going to get two spots that it touches the x-axis, like this one here and this one here. Now you might be thinking, well, why is this one positive? Why is this one going up and this one is going down? So what happens is if A here, if A is greater than 0, then you're going to be painted up. Yeah? And if A is less than 0, then it'll be pointing or fading down. And so what does that mean? That means this is a positive number for the A, and this one is a negative number for A, and that's all that really means. Okay, moving on. So what does this bring us? Well, we're trying to get closer and closer to graphing. So let's see how we can use this. Just so you guys know, I am going to be bringing, I'm going to have to make a trip to the classroom. I haven't gone inside the classroom since I left the last day. And so hopefully everything is still there. And I'm going to be able to bring my small little whiteboard back so you guys will have more of a face-to-face with me, because this just isn't working as well as I hoped it would. It's the price I pay for not having a adequate machine. But hopefully this is making sense to you guys. Let's see here. Okay, so going back to this. So what if we had the third option? What if we had a C option where it was y equals x squared plus 6x plus 9? Well, then when we factor this thing, we would get something like x plus 3 and x plus 3. Well, that's the same thing. So we would say that is x plus 3 squared. And that would make this thing look like x plus 3 equals 0. So x equals negative 3 again. So here at negative 3, we would come down, we would touch it, and we go right back up. And that would be that. And so this one, you would see, would look more like option 3. So this would be graph 3 in your notes. Okay. And so that's when we have what we call a perfect square. So it's the same factor times the same factor. What else can I show you on this one? I think this one's pretty much close enough to being it. I do want to show you more on graphing later and how to get a little bit more stuff. But some of you have asked me about factoring, like what if I can't factor? What if they're not factorable? How do we know if they're factorable? Or do I just am I just not good at factoring right now? Or sometimes they're just very difficult and you're just not seeing it. That happens to all of us. When I was in high school, we just had the guess and check method. There was no method. So I am going to give this to you a little bit early. This is about a chapter early, but I am going to give you this. So how do we know if it even crosses the x-axis? What happens if it is like graph 4 and it doesn't touch the x-axis at all and we're wasting our time factoring? How could we figure that out? So we have a method. It is b squared minus 4 times a times c. Now, you might be thinking, where does that come from? So remember, we have ax squared plus bx plus c. So that, you've guessed it, we have an a for the a, the b for the b, and the c for the c. And so if b squared minus 4 times a times c is greater than 0. So if I plug in these numbers and it multiplies to be greater than 0, that means I'm going to have two what we call roots, or two spots that it crosses the x-axis. That's called the root. If b squared minus 4 times a times c is equal to 0, if it is equal to 0, then we're going to have one root. which is going to look like this last one we did on part C, which will make it look like number 3, like graph number 3. It'll only come down and it'll touch the x-axis and then it'll come right back up. And then the last one is what if b squared minus 4ac is less than 0. That means that we get a negative number, and if it's a negative number, then we have no roots. And that means that it's not going to touch it, and it's going to be like graph number 4. Either it's going to be flipped up or it's going to be flipped down, and it's not going to touch the x-axis at all. So let's do a little quick example of some of these. Hopefully you have these down in your notes. If you don't, you can always pause and go back. So we'll do a little quick example of what each of these would look like and how to calculate this. So let's say example, we have that x squared plus 6x plus 9 that we talked about, that part C. And we factor it out, and we got the x plus 3 and x plus 3, and we know that's x plus 3 squared, right? That was our factors. So let's think about doing it with a, b, and c. So what is a? A is 1, right? There's like a 1 right here. There's like a 1 in front of that x squared. So a is 1. B is 6, and C is 9. So when we do this problem, you're going to see that we're going to get b squared, so there's b, so 6 squared minus 4 times a is 1 and c is 9. And when we work this problem out, we get something like 36 minus, and then we get 4 times 1 is 4, 4 times 9 is, oh look, 36. And 36 equals 36, so when we subtract them we get 0, and again you can see we're going to get 1 root. 1 root. So if you could see that's how it's going to look, that's because of this factor here. You only have it touch 1 time. Okay, let's try a couple other ones. So let's try example number 2. Let's say x squared plus 3x, let's say plus 15. And this would be something like a is equal to 1 again, because there's a 1 in front right there. B is 3, and c is 15. And so our formula again is b squared, so 3 squared minus 4 times 1 times 15. And we get something like 9 minus 60, which would give us a negative 54. And you might have guessed it, this is negative, and anytime this is negative, we're going to have no roots. So we could try and try and try, but we're never going to be able to factor example number 2. There's no roots. That means that this is probably going to look something like that, where this number right there is going to be at 15. So it's not going to cross the x-axis. Let's try one more. So let's say let's give a different number. Let's try 2x squared minus 2x minus 8. So a is now 2, b is negative 2, and c is negative 8. So we have negative 2 squared, which remember you need to be careful about because that's going to be a positive number. Anything squared is positive, minus 4 times 2 times 8, negative 8. And so again, we're going to get a 4 right here, and we're going to minus, and we got 4 times 2 is 8, times negative 8 is negative 64. So you got to really pay attention to your signs. Notice that we have 2 negatives, which are going to make positives, and we get an answer of 68. So again, the answer is a positive number. This b squared minus 4ac is positive, so we're going to have 2 roots. Now, just because we have 2 roots, this is the last thing I'm going to talk about, just because we have 2 roots doesn't necessarily mean it's factorable. It just means that it does cross the x-axis. That's a very big difference. So being factorable doesn't mean that that it crosses, well, if it's factorable, it always crosses the x-axis. If it crosses the x-axis, it doesn't mean it's factorable. It could be a decimal. So we could end up with something like 2.1 and 3.68. And of course, those are spots that it crosses, but that doesn't mean that it would be an easily factorable problem. So in this case, we would have to do a different solution, which you'll find out in Chapter 9. So I hope this explains things a little bit better, and I will talk to you guys again on Wednesday.